Hello everybody. Today we want to discuss pipeline transportation system. Canadians rely on natural gas and the product made from crude oil to meet more than two-thirds of their needs every day. For example, 94% of transportation demand in Canada is supplied by refined petroleum products, and more than half of Canadian homes are heated by natural gas. There are many ways to deliver these products to Canadians, but in fact 97% of Canada's onshore oil and gas are delivered by pipelines from producing regions to markets throughout Canada and the United States. So let's get into know the pipelines. Pipeline is a type of long-distance transportation method that is mostly used for liquid and gaseous material via pipes. It is a special designed mode of transporting oil, coal, and natural gases directly to the market from the place of production. The latest data in 2014 gives a total of slightly less than 35 million kilometers of pipelines in 120 countries in the world. So why are the pipelines developed so widely? The pipelines indeed have many advantages over other transporting methods. Well, first, pipelines feature to higher transportation capacity. A 720 mm of diameter pipeline can transport 20 million tons of coal in a single year, which is quite a decent amount. Pipeline has a relatively less amount of construction work. It only requires laying the pipe, building pump stations that requires less volume of earthworks compared to railway construction. Especially on the plain, most of the pipes go underground. That does not occupy farmland. Pipeline also has an advantage that is unique from others. It produces very small amount of pollution to the environment in transportation. In addition to this, pipelines have some other minor features that pushes it to the focal point of many countries' construction development. Pipeline system cannot be built and operated by one man's power. It requires a lot of coordination between different disciplines. There are three major disciplines that are actually related to pipeline system. They are civil engineering, chemical engineering, and mechanical engineering.
Civil engineering is the most directly discipline that is associated with the design and construction of pipeline transportation system. Different terrain and geology require different measurements and designs. For example, when pipelines go through the desert area, it's impossible to use a design for plan because of the instability of sands. Also, in solution for permafrost region and pass through for large rivers and so on, needed special targeted disposal measurements. Meanwhile, engineers need to compute the cost of the project and choose a lower cost and higher efficiency design from many suitable plans. These technical problems are very complex, and knowledge in civil engineering is crucial. Civil engineers need to consider not only the environment factors contributed to construction, but also the maintenance after the pipeline put into operation to keep the tenure of use as long as possible. In normal times, examination and overhaul are very important, so they can avoid some unnecessary errors. On extreme weather, civil engineers need to find out the methods to make sure they are in working order, and if problems occur, they need to repair them in a short time.
For the chemical part, we would like to analyze from two aspects. Mass and energy balance is very important to ensure the inlet and the outlet, as the whole system is made up with several pipelines that are close with each other. No matter the gas or oil transfer, the mass and energy will be balanced to make sure there is no leak, and the energy of the products is not too high. As the higher the energy, the more unstable the product.
Gases and oil are somewhat to be toxic or flammable, which is essential to make sure the container is safe for transfer. Additionally, sometimes it would be erosive for some material, so to be an engineer, we need to check it and make sure they are safe even if they are underneath. Also, the flow rate of the products, if there is the velocity, the energy will be transferred into the product. If the temperature increases, there will be some risks.
Besides from chemical engineering and civil engineering, mechanical engineering is also tightly bonded to pipeline transportation system. Here's a simple definition of mechanical engineering. Any movable object that is man-made would be in the category of mechanical engineering. By this definition, we can tell that mechanical engineers are responsible for all moving mechanisms, from those big pumps in the compression station to every single little screw connecting the pipelines. If they are not set up to the right compression ratio or not screwed in with the right amount of torque, the result could be catastrophic.
As we have learned so much about pipeline system, what is its impact on our society? Well, the impact can basically be grouped into two categories: economy and politics.
As we all know, fuels made from petroleum and natural gas are the foundations of modern industry. Therefore, the guarantee of energy supply is crucial to the world powers like America, Europe, and China. On the other hand, because of the huge amount of demand in energy, resources-rich countries like Russia and Canada benefit greatly thanks to their abundant petroleum resources. By this, I believe most of us should realize how much oil and natural gas mean to the world. However, most oil-demanded countries are far away from oil-supplied countries, and this means the transportation of oil has become a big problem to these countries as well as the global economy. Unlike seaway or railway transportation, pipeline transportation is always the most preferred way of transporting oil and natural gas, not only because of its low cost, but also its stability. Since pipelines mostly go by a shortcut that directly to its destination, so pipeline transportation is much faster than marine transportation. Furthermore, with the same distance and amount, transporting with pipelines only costs about 1/7 as much as transporting by railway. Nevertheless, building more pipeline enables local firms to earn more and hire more workers, and also makes the construction brigade to recruit more engineers in order to meet the estimated time period of construction. While more people are getting a job, they will demand more so that the economy can become lively again, and that's how economy break away from a vicious cycle. Pipelines also have a heavy impact on geopolitics and international security. It enhances international relations as a community of interests. Great powers could use the pipeline as a measure to control regional political situation. Also, interest conflicts in pipelines can lead to chain reactions in politics. The worst case is the creation of a political crisis. Here is the example. The gas pipeline between Russia, Ukraine, and Europe. Europe relies heavily on Russia's natural gas, particularly in winter for heating. Back in 2009, a dispute between Russia and Ukraine, ostensibly overpricing, led to a major political crisis. In return, Russian state-owned gas company cut off the pipeline gas to Ukraine, and also the gas supplies to Southeast Europe and Central Europe, create a crisis between the European Union and Russia. At the end, European Union could only compromise with Russia in order to get their gas back on.
The success of the pipeline transportation is the result of perfect coordination across different disciplines of engineering. However, if one single discipline fails, it could bring disaster to our society.